Welcome to another video on thinking functionally. I'll be covering the Elm architecture and building graphical web and desktop apps fully functionally. Elm is a functional language created specifically for building robust web applications, and it has introduced a unique architecture to build UIs fully functionally, and this architecture has now been implemented in many functional programming languages, for example F# via the Elmish library. To start, we'll begin by briefly covering some other common UI building patterns. The simplest, now obsolete, pattern is generally used in frameworks like WinForms. That's wrong. The simplest, now obsolete pattern that is generally used in frameworks like Windows Forms is called code behind. Here, your code manually modifies the components on a view by setting object members, and you can subscribe to event handlers of the UI components to accept user interaction. This method is super simple and works great in an object-oriented style, as you simply modify the view components and you're done. Also note that object access can go both ways, while event handling is purely one way, as shown by either side of this arrow. A more modern, common desktop app pattern is Mvvm. In this pattern, your code, known as the model, has access to an object, the view model, which it can modify however it sees fit. The view is then generated by binding values to viewModel members. These bindings can also go both ways to make user input easier. This allows the easy modification and reactiveness of code behind, but with easier user input and a layer of abstraction for a cleaner model code. Code can still be added to an event handler, just like in code behind, to allow for things like buttons. Web developers are likely to be used to a very similar pattern to this, yet simplified, the Mvc pattern. Here, a request is handled by a controller which does any necessary backend processing such as connecting to databases. It then constructs a model containing all the data necessary for the view to have. This model is passed to the viewer, a templating engine uses it to render the view to the final page the user sees, which is done either statically on a server or dynamically on a client. Events to the controller are unnecessary in this pattern, as interactions are either handled by JavaScript on the front end or by redirecting the user to another controller or the same controller. These design patterns are common, familiar, and time-tested. However, they are designed for an object-oriented world, and once we remove immutability, the only pattern here that still works is MVC. And MVC is not really usable in any real capacity for reactive single-page applications, SPAs. Meanwhile, Elm gives us a really nice pattern to create SPAs with fully functional code, where we simply write our functional code in Elm, and it does all the behind-the-scenes processing for us. I will at this stage urge you to load up the online Elm editor and examples, and just have a bit of a play around with the language and pattern as I explain it. The way I'll be demonstrating the ideas and implementation of the Elm architecture will be building the simple obligatory to-do app. An important thing to understand about Elm is that you cannot manually modify the DOM, or document object model. Your Elm code sits inside an isolated world of idiomatic, functional, runtime error-free, high-performance code interacting with the outside world via Elm. The backbone of your Elm app is a state. We need a way to keep track of state in our application. So let's create a type alias called to-do to a record containing a string to represent the to-do contents, and a bool to represent if the to-do has been done. Then let's create a type to act as the state of our application. For now, we'll simply create a type alias to a list of to-dos called model. As we don't really want to define a custom type, just give that list a more conventional type name using an alias. Similarly, our to-do type isn't technically a custom type, but copying out the full record definition every time is a pain that we just don't have to deal with. Now we have a way to store our state, but how does Elm know what we want our app to begin as? We can tell it how by creating an initial value. Let's define a value called init with a value of an empty list, and annotate it to have the type of model. Now, we need a way for the user to be able to see the page. Let's define a function called view taking a single parameter, our model. We'll also import the div, h1, and text components from HTML and begin building. We'll add a div as the root of our app with an empty array because we don't want to set any HTML attributes. and a second array in which we will put its children. Let's add a h1 child to it, and this h1's children array should simply contain the text component with an appropriate title. Let's create a function called toDoView, taking a single parameter as input, add todo. Just as in standard code we would separate out repetitive parts of our logic into functions, we can do the same for UI in Elm. Instead of complicated components, we just use a function. In this function, let's add another div to contain our plugin view, and add a text component passing our to-do content into it. Let's import the input component, both the type and checked attributes, and the onCheck event. We now have all we need to add a checkbox to our plugin view. Add an input component, and in the attributes array specify the type of the checkbox, and checked as our to-do's done value. Now we have a checkbox that can be interacted with, we will need a way to update our state. We will create a type called message, which the UI will use to inform our code when something needs to be changed. We'll add an option for update to-do checked, with int and bool as its type. Now we'll create a function called update to deal with our state changes. And let's add both view and update to our main function so we can wire everything into Elm. Back in our update function, let's add a case block to handle our message, and add a branch for the update to do checked case. In this branch, let's modify our list to change the checked status of the to-do. Now let's finish our component by adding an int parameter to our to-do view to take the index, and having it send an event on check. Then, in our main view, let's use the component. We'll pass the model through a map to render each element in the list to render components. Now we need a way to add some to-dos. Let's import the button and span components, the placeholder attribute, and the onInput and onClick events. Then create a span to hold our input area. We'll add an input of type text with a placeholder to allude to its purpose, and a button with a text label as its child. We'll need a way for our input and button to communicate back to our app, but let's add some more options to message. I'll add input box update of a string and input add button, which doesn't need a type. Let's change our model from a simple type alias to an alias to a record to let us store the value of the text box in real time as well as the list, and we'll update our initial value to map. We will also need to update our update and view functions to deal with the new data type. Now let's add handling for our new message types. Input box update will update the values stored in our model, and input add button will add it to our list. Now we simply add an onInput handler to our input and an onClick handler to our button. This app, as you can see, now works as we intended to. However, it's missing one thing. It's really ugly. To fix this, we'll import the style attribute and add some to our root node to add margins and choose a nicer font. Let's add some more margins around our input area and start styling our to-dos. I'm going to use some flex boxes to make the checkboxes line up cleanly. And there we go, a to-do list app entirely functionally using the power of Elm. Elm may not look hugely appealing from this applied example, but not only is it significantly better the more used to it you get, it goes much deeper than this. And our code is basically guaranteed to never fail at runtime due to the compiler's strictness. And of course, if you've been following along yourself step by step, you may have noticed some of Elm's error messages. Producing may be one of the best development experiences I've ever had, with simple messages detailing what went wrong, how you can fix it, and giving you a worked example. Final source code for this to-do app will be linked in the description.